Saumil Tandon, can you hear me?
Yes, ma'am.
Okay, thank you. Next, we are going to see electron gain enthalpy. Electron gain enthalpy. When an atom, when a neutral gaseous atom takes one electron, yesterday we were talking about losing one electron. Today we are talking ulta, that is, when a neutral gaseous atom takes one electron, some amount of energy is released. What is that amount of energy released? That is called electron gain enthalpy. Which group elements take one electron? Which group elements take one electron? Anyone?
15, 16, 17.
Okay. See 17th group. See 17th group, when they take one electron, they will be attaining the nearest noble gas configuration. Neon, argon, krypton, xenon. Similarly, when the 16th group elements take two electrons, when this 16th group elements take two electrons, they will be attaining the nearest noble gas configuration. 15th group, if it is a 15th group, they have to take three electrons to attain the nearest noble gas configuration. So typical examples we'll be learning of 17th group. 17th group. In this, fluorine is very small. Very small means electron density. Only two shells are there. Electron density is very high on fluorine. Of course, fluorine will be taking one electron, but due to that already present electron density, the coming electron experiences little bit repulsion also. But chlorine, electron density is diffused because it is a bigger size one. So the coming electron will not experience any repulsion. It will be attracted only attraction is there. So chlorine takes one electron very easily. That means the amount of energy released in the case of chlorine is more than the amount of energy released in the case of fluorine. Once again, fluorine is very small, means it is highly electron denser. So the coming electron experiences a repulsion also. But in the case of chlorine, chlorine can easily attract that coming electron because chlorine size is bigger, little more bigger. So chlorine easily takes one electron, or we can say the amount of energy released in the case of chlorine is greater than that of fluorine. Now in the case of bromine, it is again bigger, means it will be coming to the next shell. That means the nucleus cannot attract that much. The nuclear force of attraction, etc., on the coming electron by the nucleus is less. So this will release lesser energy, then lesser energy, like that. So electron gain enthalpy we will be talking in terms of this typical elements chlorine. Chlorine takes one electron very easily and changes to Cl minus ion, and lots and lots of energy will be released. So we are going to electron gain enthalpy. Write down electron gain enthalpy. The amount of energy released, the amount of energy released when an electron is added to, when an electron is added to a neutral gaseous atom, a neutral gaseous atom. To convert it into a negative ion, a negative ion. If generally, if I write X in the gaseous state, when it takes one electron, it will change to X minus. X minus in the gaseous state. The amount of energy release will be having minus sign. So here, delta EGE, we call it as electron gain enthalpy. Delta H in this case is equal to minus 349 kilojoules per mole. Minus 349 kilojoules per mole. Oxygen takes one electron. Oxygen takes one more electron, then only oxygen gets the nearest noble gas configuration, then only oxygen becomes stable. So, in the case of chlorine, it is 349 kilojoules per mole. See, negative sign shows that the amount of energy released. In the case of fluorine, it is only minus 328. See, I'm replacing this by chlorine. This is chlorine. X is general. If this is chlorine, then it is minus 349. What about fluorine? F. F gaseous state. When it takes one electron, it becomes F minus. Delta EGEH is equal to minus 328 kilojoules per mole. Minus 328 kilojoules per mole. See, amount of energy released. You see the quantity, that magnitude. That magnitude, that is only 328. The reason you write, Sawmill Tandon.
Yes, ma'am.
Okay, you close your audio. Microphone बंद करो. From your microphone, lot of noise is coming. Okay, write the reason. Write the question. Fluorine has less electron gain enthalpy with a negative sign. Fluorine has less electron gain enthalpy with a negative sign than chlorine. Account. Answer. Due to the small size of fluorine, electron density is higher. Full stop. The incoming electron experiences repulsion also, not only attraction but repulsion also. Full stop. But in chlorine atom, electron density is much more diffused electron density is much more diffused. You draw this box and write one question. First you draw this box, fluorine value, chlorine value, oxygen value, sulfur value. Similar, same is the reason for oxygen and sulfur. Similar reason. What we have written for fluorine and chlorine. Same reason we'll be writing for oxygen and sulfur. So write down the question. Oxygen has less electron gain enthalpy with a negative sign. Oxygen has less electron gain enthalpy. Oxygen has less electron gain enthalpy with a negative sign than sulfur. Than sulfur. Similar sentence you have to write here also. Due to the small size of oxygen, electron density is higher on oxygen. So the incoming electron experiences repulsion. But in sulfur atom, electron density is much more diffused. One more question you write. Same question only. Highest amount of energy is released. Highest amount of energy is released in the case of chlorine. In the case of chlorine, than F. Why? Than F. Why? Same answer, similar answer, you can write there also. Will noble gas take any electron? No, it will not give any electron. It will not take electron. So noble gases, write down noble gases. Noble gases. Noble gases do not accept any electron. Noble gases do not accept any electron. If you want to add one electron to noble gas, then energy is to be supplied. That means noble gases have positive EGE. Write down. To add one electron. To add one electron. To add one electron. In such cases, or in such a case, energy is to be supplied. Energy is to be supplied. Energy is to be supplied means Eg is positive. Positive value. That is, noble gases have positive EGE. Noble gases have positive EGE. Next question. Which of the following will have the most negative EGE and which the least negative? The most negative EGE and which the least negative? Phosphorus, sulfur, chlorine, fluorine. Phosphorus, sulfur, chlorine, fluorine. Now sulfur, chlorine, fluorine, they are here. Where is phosphorus? Here it's nitrogen. Here is nitrogen and here is phosphorus. Phosphorus, you see the trend. Chlorine minus 349, sulfur minus 200. So here, least negative will be of phosphorus. Most negative is for chlorine. So write the answer. In a period, EGE is more negative. EGE is more negative from left to right. From left to right. In a group, that means towards down. In a group, EGE released. Okay, generally you write in a group, it is less negative. In a group, it is less negative. In a group, these are the special cases. Sulfur and chlorine, these are the exceptional cases. In a group, it is less negative. Means when we come to bromine, iodine, like that. By considering the electron density on fluorine, it is having lower value. Value means magnitude. Lower value than Cl. Value का bracket में लिखो magnitude than chlorine. So the order is, what is the order? Phosphorus, sulfur, fluorine, chlorine. So the most negative is for chlorine and the least negative is for phosphorus. Most negative is for chlorine, this 349, and the least negative is for phosphorus. In a group, the value decreases actually. These two are exceptional cases. Next, we are going to see electronegativity. Periodic table. If you go through the periodic table, on the top right side, there's nitrogen, oxygen, fluorine, chlorine. These are electronegative elements. Nitrogen, oxygen, fluorine, chlorine, sulfur. These are electronegative elements, means from a covalent bond, they will be attracting the shared pair of electrons. It is the ability to attract the shared pair of electron towards an atom in a covalent bond. For example, HCl. Shared pair of electron, when we show, it should be right at the center. Okay. Now, when this pair of electron is attracted by chlorine, then we will show that pair of electron more towards chlorine. That means chlorine is having the advantage of hydrogen's electron. So chlorine will be developing a delta negative charge on it. At the same time, hydrogen is losing, so we write a delta positive charge on hydrogen. We say now the bond is polar. Now it is a polar covalent bond. Why this bond has become polar? Due to the higher electronegativity of chlorine. So chlorine is more electronegative. If it is HF again, fluorine will be developing a delta negative. This is delta positive. Fluorine is the most electronegative element. Electronegativity can be measured by different scales. The highest electronegativity is for fluorine, which is equal to 4. Electronegativity of fluorine is 4. So write this example, then we will be writing the definition. Write the definition. The ability of an atom in a chemical bond, to attract the shared pair of electron, towards itself, towards itself is called electronegativity. It has no unit. Electronegativity of fluorine is the highest. Which is equal to 4. Nitrogen 3, oxygen 3.5, fluorine 4, then chlorine 3, sulfur 2.5, and phosphorus 2.1. See, these are the electronegativity values for some of the elements. So, see, nitrogen and chlorine both are having same electronegativity. Still, nitrogen is more efficient in taking electrons than chlorine because of its smaller size. So then that nucleus can attract that pair of electron. That nitrogen can attract the pair of electron more closer towards it. So the efficiency of nitrogen is more as we compare the case of chlorine. Now, what about this electropositivity? These sides are electropositive. Metals are electropositive. Here we were dealing with these values, that is electronegative, most electronegative 4, then 3.5, this is 3, then this is 3, this is 2.5, then this is 2.1. So electronegative elements here, and this side electropositive, highly electropositive. All the metals are electropositive. All metals are electropositive. So metals are electropositive. Electropositivity means the ability to release the electron. It will not attract. It will be, these things are ready to give away electron, but these things are ready to attract electrons. So the metals are electropositive. This is again metal. These D block again metals. Here also metals. Here only 14, 15 non-metals are there. Non-metals are electronegative while metals are electropositive. Next, we'll be doing periodic trends in chemical properties. Periodic trends in chemical properties. Heading periodic trends in chemical properties. That will start tomorrow. Thank you.